Hello everyone, we come to question 33 of the mock test for physics. Let's quickly read what the question says. The question says that a thin wire of 66 centimeters is fixed at both ends as shown in the figure, which we'll see in a minute. The wire is kept under a tension and is divided into three segments of lengths L1, L2 and L3 as shown. When the wire is made to vibrate, these segments vibrate respectively with their fundamental frequencies in the ratio 1:2:3. The question asked is what is the length of each of these segments, that is L1, L2 and L3. The figure is given to us as shown and the options are the lengths 18, 12 and 36 centimeter, or 12, 18 or 36 centimeter, or 36, 18 and 12 centimeter, or finally 36, 12 and 18 centimeter. And the correct answer to this question comes out to be option C, that is 36, 18 and 12 centimeter. Now before we start solving this sum, I want you to take a good look at this figure that they have given to us. Basically you have a string which is held under tension, and this string is divided into three segments because of these knife edges, and therefore you have these three segments L1, L2 and L3 respectively. But what does this figure remind you of? It reminds you of something known as a sonometer. So let me quickly recap with you what exactly is a sonometer. Now in a sonometer, what happens is that you have a string which is placed under tension between 2 points, and this string is divided into segments using these knife edges, and we move these knife edges so that we can change the length of the vibrating string. Once you have put the knife edges in place, what we do is we take a tuning fork, and this tuning fork is hit on a rubber pad and placed on top of the sonometer. Now the prongs of the tuning fork move, that is they vibrate, and that vibration causes the box to vibrate, which causes these strings to vibrate, and because of this the strings vibrate with a certain frequency, and this is nothing but the working of a sonometer. Now this was the experiment that I wanted to recap. Now let's take a look at what do we know that is given to us in this sum. The first thing they've told us is that the length of this string is 66 centimeters. As you can see, they've told us that this length is 66 centimeter, and this string is divided into three sections. So you have L1, L2 and L3, and because this whole string is 66 centimeters, I can write down that L1 plus L2 plus L3 is 66 centimeter. Now they've also told us one more thing. They have told us that the fundamental frequencies are in the ratio 1:2:3. So I will also write down that the fundamental frequencies are in the ratio 1:2:3. Now these two are the only two things that I know. I'm going to need it, so I'm going to take it and place it in my given section. So I have L1 plus L2 plus L3 is 66, and F1 is to F2 is to F3 is 1:2:3. The final piece of information that I'm going to need to solve this sum is to recall what is the formula for the fundamental frequency of a stretched string. And if I recall that, then I can see that F is equal to 1/2L root T by M, where T is the tension under which the string is placed, F is the fundamental frequency, M is the mass per unit length, and of course L is the length. Now take a good look at this formula. From this, I'm going to write what is known as the law of length. And what is the law of length? The law of length says that the frequency of vibration of a stretched string varies inversely as its resonating length, provided its mass per unit length and tension remain constant, which is very, very obvious from this formula. Basically, it's saying that this portion, that is the frequency, is inversely proportional to this portion. As you can see, one is in numerator and one is in denominator. Therefore, it has to be inversely proportional. But all this is okay only if T, that is tension, and mass per unit length, that is these two things, are constant. Now, if they are constant, then I can say with guarantee that F and L must be inversely proportional, and that is exactly what is known as the law of length. So, frequency is inversely proportional to the length of the vibrating string. This is something I'm going to need, so I'm going to place it right beside the piece of information which is in my given section. So these three things are very important to me. Now let's solve the sum. The first thing I'm going to use is this law of length. F is inversely proportional to L. Inverse proportionality means that F1 upon F2 will be equal to L2 upon L1. That's exactly what I mean by inverse proportionality. Now, once I have this, I'm going to look at this portion of the given section. F1 upon F2 means nothing but F1 is to F2, and that is nothing but 1 is to 2. So, I replace F1 upon F2 with 1 upon 2, and therefore, from this I get the relation that L1 is to L2 is 2 is to 1, and I call this equation 1. I once again use the law of length, that is F is inversely proportional to L, to write down that F2 upon F3 must be equal to L3 upon L2, because that's what inverse proportionality means. But I have been given what is F2 upon F3, that is this portion of my given section. So F2 upon F3 will come out to be 2 upon 3. I replace it here, and this gives me my next equation, that is L2 is to L3 is 3 is to 2. Now these two are the equations I need, so I save them on my board. Now using these two equations, I am going to find my answer. Look at this, L1 is to L2 is 2 is to 1, and L2 is to L3 is 3 is to 2. But now I can't write it in the way that L1 is to L2 is to L3, because I don't have a common middle portion. To get that common middle portion, what I do is I multiply equation 1 by 3, and if I multiply that by 3, which is allowed because it's a ratio, then I get L1 is to L3 is equal to 6 is to 3, and then I rewrite equation 2, that is L2 is to L3 is 3 is to 2. Now you can see that the middle portion matches, so I am allowed to write it in one line, that is L1 is to L2 is to L3 is equal to 6 is to 3 is to 2. Now this is the ratio between the three lengths. What else do I know? Now recall that I also know that the lengths match up to 66 centimeters. That is L1 plus L2 plus L3 is 66, but L1 is to L2 is to L3 is 6 is to 3 is to 2, which means that they are all in this ratio, and there is some common factor which we need to find. So I write this as 6s plus 3x plus 2x is equal to 66, where x is the common factor which we need to find, and therefore this becomes 11x is equal to 66. This gives me that the common factor is 6. Once you get x is equal to 6, it's very simple. To find the lengths of the strings, I write 6x is equal to 6 into 6, that is 36 centimeters. That is the length of L1, because that corresponds to the 6th part of the ratio. Then I have 3x, which is 3 into 6, which is 18 centimeter. That's the length of L2, because that corresponds to the 3 part of the ratio. Finally, I have 2x, which is 2 into 6, which is 12 centimeter, which is the length of L3, because that corresponds to the 2 part of the ratio. And therefore, this gives me the lengths that I require: 36 centimeter, 18 centimeter, and 12 centimeter. And this is the answer. That is the lengths that we want, that is L1 and L2 and L3 are 36 centimeter, 18 centimeter, and 12 centimeter respectively. I hope you understood this solution. Thank you for watching.